The last thing we want to look at in this unit of complex numbers is looking at regions in the Argand plane. Okay, we've seen how to sketch lines, rays, circles, ellipses. We also now want to look at sort of combinations of those, and particularly regions. Regions are described by complex inequations. Okay, so an example would be here. The modulus of z being less than or equal to 1. It's an inequation because we've got this less than or equal to symbol. Now, for this particular example, we want to sketch that region, okay, that represents the complex numbers z such that the modulus is less than or equal to 1. Let's think for a moment what the modulus of z equals 1 means. Okay, if we are to sketch this, this is saying what is the locus of all the points, the locus of all the complex numbers that have a distance from the origin of 1 unit. And we remember that was represented as a circle with a center at the origin and 1 unit from the origin. Okay, so that is the graph of the modulus of z equals 1. But we've got the modulus of z less than or equal to 1. So that will include our line here, or our curve. That's part of the solution, but it's also all those that are less than that. So what we do is we shade in that region. It encompasses all those values that are less than 1 unit from the origin, which will take us all the way inside. And so that's what we've got here. We've got this shaded section inside that circle. Okay? Hopefully that's clear. Now, because our circle itself is included in the solution because it's less than or equal to, okay, the equal to sign means that it's included, we have a solid line as opposed to a dashed line. If it was just less than, then we would have a dashed line to show that it's not part of the solution. It's like the boundary, but it's not included. So let's have a look at our second example. We want to sketch the region represented by z, a set of complex numbers, such that z plus 2 minus I, so the modulus of z plus 2 minus I, is greater than 2. Okay, so we need to think, what does z plus 2 minus I, what does the modulus of z plus 2 minus I look like as a graph? Well, we know the modulus of z is a circle with a center origin. This one is going to be a circle with a center at -2 plus I. Okay, so we go 2 units to the left and 1 unit up. Right, so it's going to be around about here, and we've got a circle there, a very dodgy circle. If we have a look over here, it's much better. Okay, so that circle is the circle. However, notice as when we've graphed it over here that now it's going to have a radius. Okay, note that down, a radius of 2, because we're just looking at the circle here, which is equal to 2, the radius of 2. So because it's 2 to the left, that actually should come and just touch that, shouldn't it? Okay, just to touch that point there, and that's what we've got here. So the circle comes around and we have a tangent here on the imaginary axis. Alright, now notice that it's greater than 2, so that the circle itself is not part of the solution. So we show that using dashed line rather than a solid line. and because it's greater than 2, it's going to be shaded, hatched, coloured in, whatever you like, outside of the circle. Okay. All right. Let's move on to the next example here that's shown on that's given in the notes. We want to indicate the region of the Argand plane which represents the complex number z, such that the argument of z is between negative pi and pi on 3. Now let's think of it as in two parts. Well, first of all, we notice here that these less than signs means that there's going to be a region shaded. But let's split it up into two parts. Let's look at this bit here, the negative pi less than the argument of z. Okay, so that would be the same as saying the argument of z is greater than negative pi. So if we just think of that in itself, okay, we know negative pi is out here, but it's the argument is all the angles greater than negative pi. Now if arg z is equal to negative pi, we know that it's going to be along this line itself. Okay, but all the angles greater than negative pi means it's going to be all of these here. Okay, so we'd go all the way around, and we could keep going around, okay, because as we go clockwise, all of this area is going to be shaded because it's all greater than negative pi, but this just happens to be the starting point, okay, on this side. But then let's think about the other part of what we've got. We've got the argument of z which is less than pi on 3. So the argument of z less than pi on 3. Now, if for argument of z equals pi on 3 represents an angle that comes up here. Okay, so pi on 3 measured from the positive real axis. That's what we have there. Now, what we can see is that the argument of z is all angles less than pi on 3. So what we want really, I'll change pen colour here to green, it's all of these angles less than. Now if we go less than, it's going to go round here and even into the negative, and we can go all the way around the other way. But we want all the complex numbers that are represented by both of those holding at the same time. Okay, both of these holding at the same time. So it's going to be clearly from negative pi around to and stopping at pi on 3. So it's just that section there. Okay, now I can see there's a bit of a problem. Okay, what we really need to have on there, and you'll need to correct that, is that this line here should be dashed. Okay, so just correct that in your notes. Okay, you had it as solid, but it should actually be dashed because we notice that it's less than pi on 3 and not less than or equal to, so that line should not be included in the solution. Okay, so that's there what it should look like. Okay, so we've got here our axes, imaginary and real, and then going off at an angle of pi on 3, our dashed line here. Make sure you put in the angle, and here we will also, I'll change the colour, put a dashed line heading out in that direction as well, because that is important. Okay, putting our angle there, and we will shade that region from negative pi round to pi on 3. You'll notice here that that's not also didn't complete that properly on this diagram, so really we should have that, whoops, as dashed line through to there as well. Okay, we just need to indicate that. Alright, because if it was less than or equal to, then we would have to show that as a solid line there. Same here, if that was less than or equal to, then this would be a solid line. But as it is, they need to be dashed. Okay, we'll leave it at that, and in the next video we'll go through some more examples.